finish valence shell electron pair repulsion theory. All right. Can you see my slide? VS-EPR model.
Yes, sir.
Okay, we talked about starting with Lewis structures, how you get the molecular shape. When you look at methane, it has central carbon atom is the one we look for to predict shape. Central carbon atom on methane. There are 4 electron pairs. Normally 4 electron pairs distribute in around carbon atom in a tetrahedral way. Ammonia has 3 bonding electron pairs and 1 lone pair. Here, lone pair. When you have a lone pair, it changes the shape. Lone pair doesn't show up in the molecular shape. Therefore, you see only the bottom 3 hydrogen atoms and the one on the top, nitrogen. The shape is pyramidal. Water has 2 lone pairs. Therefore, it changed to a water shape is bent or angular. The angles need to be remembered. Tetrahedral angle is 109.5. In ammonia, it is 107 because 1 lone pair pushes the bonding electron further down. When you have 2 lone pairs on the oxygen in water, it pushes further down. Water molecule has 104 compared to 107 in the ammonia. Now, when you have 3 bonding pairs in the carbon atom, 2 carbon atoms here, there are 3, 1, 2, 3. The first 1 and 3 is a single bond electrons. Second one is in the middle is a double bond. There are 3 groups of electron pairs. The 3 group of electron pairs indicated here, 4 electron pairs, distribute around the central atom, bonding electron pairs, distribute around the central atom, carbon, in a trigonal plane. Therefore, formaldehyde is, ethylene is trigonal, 2 trigonal planar molecules in a plane, it becomes a planar molecule. We talked about this. Formaldehyde becomes trigonal planar. We just call it planar. Carbon dioxide has 2 electron groups. Therefore, 2 electron groups normally distribute in a linear fashion. 3 trigonal planar, 4 excluding lone pairs, tetrahedral. So, ethylene molecule we talk is linear. So you have to answer the question, what is the molecular shape of water? Water is a bent, ammonia is pyramidal, tetrahedral for methane, planar molecule, formaldehyde, both formaldehyde and ethylene. Carbon dioxide and acetylene are both linear molecules. Now we done the Lewis structure part, and all we need to predict the polarity of a molecule. Let's go to the idea, how you predict the polarity of a molecule. Polarity of molecules are important. Molecules have polarity when they have charge separation in the molecule. Therefore, in the molecule, there's distinct regions where positive charge is there, negative charge of electrons there in the last shell, valence shell. For a molecule to become a polar, there are two conditions. One, all the bonds in the molecule, at least some of the bonds in the molecule should be polar. They need to contain polar bonds. A polar bond is a bond where there's a separation of charge. The atom here is more electronegative. Electronegativity is, this atom is greater than that one. So electronegativity decide of a bond, decide whether bond is polar or not. We're going to look into this in detail. So when bond is polar, there's a positive charge, partial positive charge. We call it delta positive. For example, hydrogen and oxygen. It's a polar bond. We're going to talk about it. Electronegativity of oxygen is greater than electronegativity of hydrogen. So partial negative charge coincide with the atom with higher electronegativity here. Partial positive charge with the lower electronegativity. The partial separation of bond electron pair towards one atom is due to electronegativity difference, create a polar bond. Now there's one thing. First thing is molecule has to have polar bonds, but geometry of the molecule has to be considered. For example, carbon monoxide is a linear molecule. There's a negative charge here, negative charge, positive charge in the middle. Therefore, dipole, written as, you're going to see dipole, how the arrow is represent dipole. When polar forces compete in a line, they cancel out. But because the molecular polarity, polar bonds cancel out, carbon dioxide is not polar, non-polar molecule. So you get the idea. You have to find out whether the molecule has bonds with polarities, polar covalent bonds, and decide whether they cancel out due to the arrangement or geometry, shape of the molecule. Carbon dioxide is linear, it cancels out. So we're going to look at more examples. If you had to guess water molecule, what do you think the polarity of the water molecule is? Polar or non-polar? Water is a polar molecule. Normally, non-polar molecules are gases. Polar molecules are liquid, sometimes rarely solids. Ionic compounds are solids. So therefore, properties of different compounds depend on whether it's ionic, polar covalent bonds, polar molecules, or non-polar molecules. Therefore, it's important to know the polarity of a molecule to decide the physical properties, melting point, boiling point, etc. Water has two polar bonds because of its geometry. Geometry is linear. I wrote down here. This water has two bonds. The polarity is aligned with the arrow, two dipoles. Therefore, these two dipoles, I'm sorry, I wrote it in the wrong way. Negative end is the arrow. Two poles. When they go this way, forces, they add up. So therefore, there's a resultant negative end and positive end the ball. This is the positive end of the dipole of the water molecules. That's the negative. Therefore, water is a polar molecule. You look at the polar bonds in water molecule, they don't cancel out like in carbon dioxide. Ammonia is similar story, polar. There are three polar bonds. How do I know ammonia is polar? Polar bond. NH bond is polar. How do I know? We're going to show it in a minute. This is polar. This is polar. Why? The chlorine bond is carbon hydrogen bond is non-polar. These two are polar. The negative end is on here. Positive end is here. Negative end is here. Positive. So they add up. So is the carbon formaldehyde. There's a polarity. Carbon hydrogen bonds are not non-polar. Only polar bond is this. Therefore, this doesn't cancel out. So that's how we argue. Acetylene molecule is non-polar because like carbon dioxide, this has a linear shape as well as carbon hydrogen bonds are non-polar. Carbon triple bond is non-polar either. So it's a non-polar molecule regardless of the shape. So this is the carbon, this CH, first one, CH2, Cl2. Therefore, it's a polar molecule. There's a polar molecule as well. I talked about this. Now, when you look at to predict the polarity of a bond, I may have to go back a little bit. I went way down. Polarity of covalent bond. There are two types of covalent bond. We talked about non-polar covalent bond. Non-polar covalent bond. Non-polar covalent bond. I cannot do it. Non-polar covalent bond. Right here. Polar covalent bond. How do you know molecule have polar covalent bond? The equality of sharing depends on the electronegativity. If they are unequal electronegativity, it creates a polarity. This is the diagram. If the electronegativity difference is less than 0.5, it's a non-polar covalent. carbon hydrogen bond is nonpolar. It's between 0.5 and 1.9 is polar covalent bond, OH bond, HF bond, etc. Non-metal, metal, metal, non-metal, metal, non-metal combination gives greater than electronegativity difference greater than 1.9. So therefore, you can predict the polarity. For example, if you have a question like this, what is the electronic bond between, what kind of bond between carbon and sulfur going to be formed? Both have same electronegativity. When you look at the chart, therefore electronegativity difference is 0. Therefore, non-polar covalent bond. In here, nitrogen is, ammonia, nitrogen is 3.0, 2.1 hydrogen. So it's 0.9. 0.9 is between 0.5 and 1.9 within this range. Therefore, polar covalent bond. So this one is a polar covalent bond. That's how you predict the polarity of bond. For example, ionic compound. Fluorine has higher electronegativity. That's the one. It should be greater. When you subtract this, 3.1. So you can see it's greater than 1.9. Therefore, it's ionic. So that's how you predict the polarities of right here. We gone over this a few minutes ago. So how do I know CH, chlorine bond, is polar? I subtract chlorine electronegativity, then find out this is greater than 0.04 polar covalent bond. So therefore, CH2Cl2 has polar covalent bond. They don't cancel in the geometry. Therefore, they are polar. So we finish chapter 3. I am going to go to chapter 4 slides and start from there. Can you see my chapter 4 slide table now? Can you guys see chapter 4, chemical reaction and energy?
I see chapter 3, chemical bonds.
Okay. All right. I may have to stop sharing then. Can you see my chapter 4, chemical reactions and energy calculations?
Yes, sir.
Okay, I'm glad I got that straightened out. Thank you for pointing that out. Okay, let's go back to beginning. So we're going to finish chapter 4 and we will have a test on chapter 4 and 3 and 4 on October 5th. So we have to go questions for chapter 3 and 4. So you should be looking at chapter 3 questions now. After you study the material on chapter 3, look at the questions in the module 2 for chapter 3. So I'm going to start the chapter 4 slides. Now we go over basic idea about sciences, scientific method, classification of matter, calculations, significant figures in calculation, etc. And in the second chapter, we talked about atomic structure, periodic table, electronic configuration, valence electrons. So we are at the point, and chapter 3, we go on bonding. We are getting into more details about how the atoms react to form ionic bonds, covalent bonds. Electronegativity is used to predict the ionic bond and the covalent bond. Naming ionic compounds, naming covalent compounds. And we look at Lewis structures of covalent compounds. And also we predicted the shape of covalent molecules like ammonia, water, methane, etc. So at the end of the chapter 3, we found a way to predict the polar molecules, where the molecule is polar or non-polar. So these ideas we develop in chapter 1, 2, 3 are expanded further in chapter 4 to discuss about chemical reactions, little more detail about how chemical reaction take place, how we represent them, and how we calculate energies from chemical reaction. Chemical reactions are reaction between element compounds, various combination of elements and compounds. So they are the starting material for reactions. Reactants are the starting material. So when they undergo chemical reaction, they change the substance and produce products. So when you write a chemical reaction, you write an equation where it shows what is your starting material or reactant, and then put an arrow and write down the products, compounds formed after the reaction. So we write down in chemical formulas, reactants, chemical formula, how they get converted to product formula. So we also have to balance atoms in the chemical equation. It's called balancing chemical equation. Atoms on the left side should be, reactant side should be equal to atoms on the product side. Now, after we done the basic idea about reactions, how we balance them, chemical reaction, we have to predict various products of various reactions that occur in solutions, or mainly solution. We do chemistry mainly in solution. Gaseous reactions are explosive. Solid reactions are slow. So mainly we do chemistry in solution, aqueous solution, water solution. We have to predict how the ions react in aqueous solution to form products. There are also reactions where electrons are transferred from one atom to the another in the reactants, and electrons are found in another atom in the product. To calculate products formed in a chemical reaction, we have to get the formula weight or molecular weight of reactants. So we need to know how to calculate molecular weight. It's simple, adds up the atomic masses of various elements in the formula, get the formula weight or molecular weight. Formula weight is for ionic compound. Molecular weight is for covalent compound. The mole concept is used in chemical reaction. Therefore, we need to convert grams where we measure. Grams is the quantum unit we measure reactants. To use the chemical equation, we have to convert grams to moles. Then moles of reactants, moles of products, then back to moles of products to grams. Therefore, there's always mole concept involved in chemical calculation. Calculating mass relationship in chemical reactions involve mole and mole concept and the mass of reactants in grams. Now, one of the other things, last thing we learn is how the heat is produced in chemical reaction. We have to calculate heat produced, how much heat is produced during a chemical reaction. We're going to look into these 8 ideas. Heat of reaction is also calculated. So I am not going to go through this instructional objective right now because we have to go through substantial amount of ideas that cover that 8 topics or 9 topics in the table of content. So let's start with chemical reactions. That's the first topic in the chapter. Chemical reactions are, what are chemical reactions? Chemical reactions are changes that atoms and molecules undergo. Atoms and molecules called reactants undergo to produce products. In a chemical reaction, one or more reactant is converted to one or more products. The reactants are either elements, molecules, different compounds. Products are different compounds, molecules, etc. So this arrow represents the transformation between reactants and products. Reactants are found on the left side, products are found on the right side. That's the chemical reaction in words. But you show the chemical reaction with formulas. So we're going to discuss 4 aspects of chemical reaction in this chapter. How to write balanced chemical equation, how to write formulas, then balance the chemical reaction. We're going to learn what kind of reaction that take place commonly in chemical reactions. There are about 4 types. We're going to look into this. We're going to look into mass relationship, how you calculate moles from grams, and how we convert moles of products to grams of product. This mass relationships in chemistry is called stoichiometric. Stoichiometric calculation involves chemical reaction and converting reactants grams to product grams. So that involves mole concept. The other last aspect we're going to look in chemical reactions, how much heat gain or loss accompanying reactions. So some reactions produce extra heat when the products are formed. They are called exothermic reactions, given out. Some absorb heat, they are called endothermic. That endo means going in. So we're going to look into these 4 aspects. So let's start with some idea about types of chemical reaction. We're going to look at writing chemical reaction in a minute. First, we start with type of reactions. Basic pattern observed in many chemical reactions is these 4 types. Synthesis reaction, where 2 elements form a compound, is called a synthetic reaction, synthesis reaction. The second one is breaking up, decomposition. A compound is broken down into simpler compound. Copper carbonate broken down into copper oxide, carbon dioxide. Single displacement reaction. One element replaces another element, that green ball here. Now this is gone in replacing this green ball with yellow ball. Only one atom is replaced. But the double displacement or exchange reaction, this is called exchange reaction also. The both are, this goes with this goes with this. These two goes with. They both are swap. So it's called a double displacement. That's depending on the pattern, basic pattern of atom exchange. Now, chemical reaction are 3 types, 5 types. Synthesis reaction, decomposition, 4 types. Single displacement, double displacement. We talked about that in the previous slide. Now, chemical reaction also follows certain reactivity of compound pattern. Compounds have certain properties. So they have common pattern, reactivity pattern. Acid reacts with bases. Ionic compound form precipitate. Redox reaction, where electrons are transferred, is a common pattern in redox reaction. Precipitation is when soluble salts, salt is an ionic compound. When they are mixed, one of the insoluble salt, we're going to look in this. Ionic compound, when their solutions are mixed, sometimes you get a precipitate. That's called a precipitation reaction. That's common reactivity pattern shown by ion soluble salt compound solution. The second one is oxidation reduction. Oxidation reduction is electron transfer. Oxidation is loss of electron. Reduction is gain of electron. We're going to talk about this in detail. So if an atom loses an electron, we call it undergoing oxidation. If atom in a compound gain electron, it's a reduction. In a chemical reaction, reactants, some of the atoms of reactants loses electron to another atom in the product. So therefore electron transfer takes place. These electrons could be used for obtaining electrical current. Therefore, electrical energy could be produced by redox reaction. The third class, main class of reaction, is acid-base. Certain compounds have acidic properties, and some have basic properties. Acids are sour, bases are bitter. When they react with each other, they form water. So these are the main 3 types of reactions that we're going to discuss. We're going to start with precipitation, go into acid-base, go into oxidation reduction. In this chapter, we focus on first. In chapter 8, we're going to talk about acid-base reactions. Chemical reactions are mainly three categories. Precipitation. These are ionic compounds, mainly salts. These could be ionic compound, but they undergo electron transfer. Acid base are reaction between acid base. Acid have certain properties. Now, if you look at the oxidation, combustion reactions are combustion when element oxygen combined with another compound is a combustion reaction. That's the oxidation reaction. Formation of compounds, synthesis reaction, are oxidation reaction. Decomposition reaction. So there are many places where we see redox oxidation reaction called redox reaction. Precipitation is mainly between salt, acid bases, between acid and bases. Now we're going to, before we go into details of these types of reactions, precipitation, oxidation, and acid base, we're going to look into chemical equation. For example, combustion, one of the redox reaction. Following equation tells us combustion of propane. Combustion is combining with oxygen. Carbon dioxide and water is produced. That's the propane. Propane is found in gas tanks you buy for gas grills. You normally do barbecue with propane. So when you look at this, carbon dioxide and water is the product. Reactants are propane and oxygen. Someone could ask, what are the reactants? You have to identify propane and oxygen, either one of them. So the question is this reaction balanced? While reactant and products are the physical state of each, this is the physical state, gas. All are gases at high temperature. Normally we drop physical state for common compounds. We know what they are when you use them often. Otherwise, we have to put the physical state in the chemical equation. Physical state could be gaseous, liquid, solid. AQ is water solution. In water, something is not liquid or solid, they are called aqueous solution, AQ. They are dissolved in, this is mainly ions. Because the number of atoms in the left is not the same as the number of right. So if you look at this reaction, is it balanced? If you look at this, there are 2 oxygens here, 1 oxygen here, then there are 2 oxygen here. Therefore, reaction is at least not balanced as far as oxygen. One, you have to find a one unbalanced, then reaction is not balanced. Even the carbon is not balanced. 3 carbons here, 1 carbon here. Hydrogen, 2 hydrogen here, 8 hydrogen here. Therefore, reaction is not balanced. You identify the physical state, reactants and products, then we have to balance the form atoms in both sides. How you balance? balancing chemical equation. This is the same reaction. You start with this one. Why I pick carbon? I pick carbon. Carbon is found in only one place, either in reactants or products. Only one place. If you go to pick oxygen, you could have start with hydrogen also. You don't start with oxygen because it's found in one place here, but in two places in the product. Therefore, how to balance reaction between these two? You balance the carbon first and then water. To balance the carbon, you count there are 3 carbon atoms. You get first 3 carbon atoms. You put a 3 in front of here. First balance the carbon. That 3 took care of carbon balance. Now you go to hydrogen. Hydrogen is 8 here. This is 2 here. You put a 4 here. Putting a 4 equals 2 times. This is 8 hydrogens now. This is 8 hydrogen. Is balanced. So carbon is balanced. Carbon is 3. Now check the oxygen balance. Oxygen is now, start with the here. 4 oxygens. How do I get 4 oxygen? 4 times oxygen. 3 times of 6. I need to write down clearly. 6 oxygen. 4 plus 6 is 10 oxygen. These together. So you have only 2 here. How do you make a 2, 10? You put a 5 in front of here. It makes 10. So therefore, balance equation have still the one. Stoichiometric is not 10. 5 here, 3 here, 4 here. So I got it right here. 3, 5. That's how you balance the chemical equation. You start with the one with the one element present in both sides to start with. Then move on to complicated, where elements are present in everywhere. We're going to do another problem. Now, this is reaction between solid state here, gaseous state, solid liquid. Calcium hydroxide. We don't go now naming ionic compound. Hydrogen chloride, calcium chloride. All right. If you look at this, calcium is balanced. Chloride is not. Therefore, to balance chloride, we put a 2 in front of here. 2. Then chloride is balanced. Now we check the hydrogen. Hydrogen is balanced. 2 here, 2 here. No. How many? There are 2 oxygens here, 2 hydrogens here. 2 plus 2 is 4. So therefore, we have to put a 2 in front of here to balance hydrogen. 2. 2 and 2 hydrogen. Get it? 4. This is 4 hydrogens. Now where hydrogen is balanced, chloride is balanced. You take the oxygen. 2 oxygens. Here 2 oxygen. Equation is balanced. Therefore, by putting 2, 2. Make the equation balance. Let's look at it. That's the balance equation. Okay, we go into the other one. How do you balance it? You don't start with the oxygen. You start with 6 carbons. 6 carbons here. Now you go to the hydrogen. There are 12 hydrogens here. Therefore, you have to put a 6 here. 6 here. 6 times 2 is 12. Then 12 hydrogens. Now you try to balance the oxygen. There are 6 oxygens here. 6 oxygens here. How do I get 6 times 1 is 6? 6 times 1 is 6. That means 12 oxygens. To make it 12 oxygens on this side, 6 is already there. Remainder is another 6. Therefore, you put a 3 here. That's 6 oxygens. 6 oxygens. Altogether is 12 oxygen. Therefore, equation is balanced. So you go back to this one. See, there put 3 6s. We got the I may have made a mistake. Okay, this is not correct. What is not correct? This is 12 oxygen. Therefore, 18 oxygens. Therefore, there are 6. Then you have to have 12 oxygens here. That make it, to make it 12 more, you have to put a 6 here. I made a mistake here. It's 12 oxygens. 12 plus 6 is 18. So that's how you got the. So similar way, when you calculate the butane combustion, there are 4, you start with carbon, 4. Then oxygen, then hydrogen. Hydrogen is 10 here. You put a 5, that become 10. Now oxygen is not balanced. 5 oxygens, 8 oxygens are here. This is added up, 13 oxygens. So 13 is an odd number. You cannot divide it by 2. You put the 13 here, divided it by 2, because there are 2 oxygens, that become 13 oxygen. So to get rid of 2, you multiply whole equation, this whole equation, stoichiometric by 2. Then you get 2 here, 13 here, 4 here, 5 here. So that's how you get 2, 13. That's 8. That's 8. 8 oxygen. So that's how you balance chemical equation. All right. When you have polyatomic ions, we talked about that in chapter 3. So they, in reaction, polyatomic ions are not destroyed. They go in the equation. Therefore, you can, in balancing, you can keep them as a group. For example, you keep these S groups. Therefore, you don't have to break up phosphorus and oxygen. Sodium is, in this equation, sodium is 3. Sodium, 3 sodiums. 2 sodiums here. How do you balance now? You cannot ever multiply by a common factor, make 2 is equal. You have to cross multiply. That means 2 times 3 multiplied by 2 times 3. 3 times 2, that makes 6 sodiums. Therefore, you put a 3 here, 2 here. Okay, sodium is balanced. When you put 3 here, sulfate becomes 3 sulfates. There are 3 sulfate groups, this group. Therefore, there's only 1 here. So you have to put a 3 in front of it. Now you check the phosphate. Phosphate is 2 here. Therefore, put a 2 in front of here. Then check the hydrogen. Hydrogen is 6, 6. Equation is balanced. The last one is always balanced by itself. So this equation have stoichiometric coefficient of 3, 2, 3, 2. So we got the same answer. 3 here, 2 here. How many of you are understanding this now? Are you guys okay with balancing chemical equations? All right. Okay, I'm going to talk about reaction in aqueous solutions. Aqueous solution is water solution. Mainly salts. Salts is ionic compounds. Are only soluble in water. Therefore, reaction between ions normally take place in water. Ionic compound, also called salts, consists of both positive and negative ions. We talked about ionic compound, cations and their names: sodium sulfate, sodium fluoride. Some salts solutions are ionic compounds or salts are soluble in water. What do you mean by soluble in water? When you put them in water, they go clearly into the solution. Sometimes they become colored depending on the ions, cations mainly. When they go into solution, they break up, ions break up, ions dissociate. Solvated ion. Solvated ion means this ion surrounded by water molecule, surrounded by. Let's look at the picture for this one. Sodium chloride is a salt. When you put in water, it goes into solution. This is solution, aqueous solution. Therefore, water solution, sodium ions goes in. When you put a sodium chloride block here, it disappears. Insoluble means it doesn't dissolve. It doesn't go into solution. They're solid. When this happens, this sodium ion is surrounded by many water molecules. This is only few shown here. Water has a dipole. We just talked about it. negative end of the water molecule pointed towards the positive. They're surrounded. That breaks up the sodium chloride lattice. So when something goes to solution, this takes place for all soluble compound. When it goes into solution, no matter what the metal is, what the anion is, they make Mx negative. I'm sorry, I'm making a mess out of it. M plus, solid ions, Y negative. So this is very common for any soluble solution, water solution. You can write down for different soluble. I'm going to show you what salts are soluble, what salts are insoluble in a minute. Let's talk about reaction between ions in solution. When you mix up different salts like that and produce aqueous solutions of salts, when you mix two ion solution, ion solution, is namely two solutions. They react, ions react with each other when one of the following can happen. Let's take an example. Okay, I'm talking in general. There are few things that can happen between ions in solution. Two ions can form a compound that is insoluble in water. You get a precipitate. Insoluble salt is formed when two ion solutions are mixed. This is called a precipitation. Sometimes bubbles form, gas form. You get carbon dioxide, hydrogen sulfide, etc. Hydrogen sulfide. So they also complete like so insoluble salt. They escape from the solution. Also, redox reaction can take place between ions in two solutions. We're going to look into first one, precipitation now. These are the, I didn't write it, gas formation reaction in the previous one because gas formation is not very common. We only talked about acid-base, redox reaction, precipitation reaction, mainly. I will give you examples of gas formation reaction in a minute. When you mix up ions in solution, water solution, what takes place? Gas formation reaction is here. A gases like carbon dioxide or hydrogen sulfide is formed. The carbonate with acid produce gases, carbon dioxide. Eggshells with acid produce carbon dioxide. It's a gas formation reaction. It's similar to formation of insoluble salt, but in place of salt, we end up with carbon dioxide that leaves the mixture, therefore complete the reaction to the product. So important reaction, one of the important reaction is precipitation. I went down to correct it. When mixing two precipitation occurs, what happens when we mix of two different ionic compounds? For example, when ionic compounds is sodium chloride is dissolved in, you get solvated ions. We talked about this. Silver nitrate is a soluble salt. It dissolves. This is silver nitrate. This is on the beaker is sodium chloride. This is the precipitate. We call it precipitate. When you add these two, they become a form of precipitate. How does the precipitate form? When you mix these four ions, I'm trying to remove this. No. There are new combination form. First one is the second one is the first one. The new combination is silver chloride, sodium nitrate. We have a table describing which one are soluble. This one is insoluble. This is soluble. Therefore, silver comes out of the precipitate as a solid. Sodium nitrate remain in the solution. That's what takes place. When you mix sodium, two solutions of salts, they produce different combination of cations and anions. That could lead to insoluble salt formation. Depends on if silver chloride or sodium nitrate is insoluble or soluble. Silver chloride is insoluble. I will show you in a minute how you get it. This is soluble. Therefore, sodium nitrate remain in the solution, so silver chloride comes out. So we write down if two or more ions combine to form water insoluble. Water insoluble is insoluble here. Insoluble is precipitate, compound form of precipitate. Therefore, to predict the precipitation reaction, you have to look at the combinations of new combinations of that create upon mixing, whether they are soluble or insoluble salt. If there's no insoluble salt form, there's no reaction. They remain in the solutions are mixed, but no precipitation take place. At least one of the salts are insoluble, that's one. Both could be insoluble. Then there is a mixture of two solids. We avoid mixture of two solids because we cannot separate. So we only get the combination where one is insoluble, one is soluble. So they can use a filter paper and separate them. So we produce salts that way. If all ions are soluble, no change will be observed. Reaction between ions. Suppose we prepare two aqueous solution. These are the same we are talking about, silver nitrate and sodium chloride solutions. If we mix the two solutions, we have four ions present. These together react to form silver chloride because silver chloride is an insoluble salt. Therefore, silver is precipitating out. This is called complete ionic equation. We add this here, this here. And combination produce silver chloride is on the product side. The other combination is not producing insoluble salt. Therefore, this is called the total. When you add these, there are 4, 1, 2, 3, 4. 1, 2, 3, 4. They added together, they produce silver chloride. This is the products of the precipitation reaction. So you can separate out silver chloride. To make it easy, we come up with a way to show net ionic equation. These are the 4 things we added up in the previous slide. Now to simplify the equation, complete ionic equation. This is complete ionic equation. We remove nitrate and nitrate here, sodium ion and sodium ion here. They are called spectate ions. Spectate ions means they didn't undergo any change. Spectators are one that doesn't participate in a sport event. Sodium, nitrate ion, sodium ion, sodium ion. They cancel from here, 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 because they are not involved in the precipitation reaction. The net ionic equation that shows what really took place in the precipitation reaction shows silver chloride is formed by combination of silver ions and chloride ion. That therefore, removing spectate ions from the net produced from complete ionic equation. This is the complete ionic equation right here. This equation, total equation here. Removing spectate ion, you get the net ionic equation. Ions that do not participate in a chemical reaction are called spectate ions. All right, I'm going to stop at this point. Are you guys there?
Yes, sir.
All right, sign up the class roll and I will see you on Tuesday. Okay, start reading about chapter 3 and 4. Okay. All right, see you.
Okay.
Have a great